Hi, kids. Oh, my God, we're back. Hopefully you watched the first half of this one, or the first third of this one. By the way, all of these videos will eventually be able to be found at www.nkinfinity.com. Now, if you're watching these in August of 2016, probably not going to be there. But if you're watching it in September of 2016 or after that, more than likely I will have time to update the website. My name is Mr. Krause. That's the K part. The N is my partner in crime, Miss Vicki Newman, who will be doing the geometry exam on next day or two. But I go by Mr. Key for today. This is part 1, problems 13 through 24. 13 through 24. So this is the second half of the multiple choice questions. Let's get going. Not on that page. There we go. So let's see what we got here. Oh man, this was a joke. Everybody got this one right? If you didn't get this one right, something's wrong. So an equation to represent the value of a car after T months of ownership is given by that. Which statement is, oh, look at there. There's our favorite word. Not. They're going to hide those. When I get mad, I drink some coffee. When I get happy, I drink some coffee. When I need to stay up late, no. Let's just keep going. Anyway, so there's that button. Which one is not correct? So the car, so notice this thing right here. This is going to tell us whether or not we have exponential growth or exponential decay. Now you need to be a discerning student and go, okay, growth means it's greater than 1. Decay means it's between 0 and whatever that value is and 1. Basically less than 1, a fraction less than 1, but bigger than 0. Shouldn't be negative as far as growth and decay goes. So this problem has 0.81. Now you would expect that for a car to lose value. It would be exponential decay. As soon as you drive it off the lot, bam, you just lost 20% of the value of the car because now it has to be sold as a used car and not a new car. So for the car to have lost approximately 19% of its value each month, well, yeah, that's about right. 19%. That's right. That is right. We don't want that. We want something not right. The car maintained 98% of its value each month. What? I mean, that's the answer, because that's stupid. There ain't no car ever going to maintain 92% of its value. The value of the car when it was purchased was $32,000. Yes, you remember, there's the starting amount. The value of the car 1 year after it was purchased is $25,000. And if you typed in T equal to 1 and typed that in your calculator, it would come out to be $25,920. So the one that is not correct is that stupid number 2. If you read the problem correctly, you got it right. If you chose to read quickly and sloppily and didn't highlight stuff, sorry, chillin'. All right. Odd function. Now, you learned hopefully, if you took this in August 2016, I don't know what you learned it last year sometime. If you're taking it any other time after that, I hope that you were taught the end behavior of an odd function. The end behavior of an odd function means it goes, the domain is infinity, negative infinity to positive infinity, but the end behavior is something like that, or something like that, where it goes up and down forever and ever and ever in infinity. Well, let's look at a sine curve. No. Cosine curve. No. Exponential function. No. Right? Right, this has an asymptote. Odd function, choice 3. Should have been an easy problem. When factored completely. Okay, the word completely kind of helps out a little bit. By the way, I'm going to show you 2 different ways to do this problem. I'm going to show you the hard way and then the easy way. Well, this is actually the easy way. The hard way is the easy way. Whatever. So, first things first, I'm going to take out my GCF, which is 2D. And when I take out that out, I got d cubed plus 3d squared minus 9d minus 27. And then I'm going to factor by grouping. I'm going to group these 2 suckers together, and I'm going to group these 2 suckers together. So I keep the 2d coming along for the ride. Out of this, I can take out d squared. I'm left with d plus 3. Out of this, I'm taking out a negative 9. Be careful, there's a negative 9 coming out, and I'm left with d plus 3. All right, so what do I got? I've got 2d. Now, they both have this in common, so I'm going to take that out, d plus 3. And then I have d squared minus 9. Now, it does say factored completely. So for those of you that picked this one, probably not the right answer because d squared minus 9 can be factored. Okay? So that's why this was a relatively tricky question. Because if you put this in your calculator and you put this in your calculator, you would find out those are exactly the same thing. But factored completely means keep going. So this was a tough question only because of that. D plus 3, d squared minus 9 is d plus 3, d minus 3. So factored completely is 2d. Notice I have two of these right here. D plus 3 squared, d minus 3. And choice 3 is the right answer. Now, had you graphed them on the graphing calculator, and again, this is a teaching video, not necessarily a, I lost track of that piece of paper. So we'll go over to our graphing calculator. We will go, let's just graph it. Let's just show, let's see what it looks like graphically. So the original was, I'm trying to find it so I don't have to keep looking back. Nope. That's 5. Where the heck is, oh, there's, no, that's 13. Where's 14? It's, all right, I've somehow misplaced 14. Ah, I found 14. There we go. Nope, there's 15. Okay, so we're going to type in 2d to the 4th, 2, we're going to use x to the 4th, get out of exponent mode, plus 6d cubed, plus 6x cubed, get out of cube mode, minus 18d squared, minus 18x squared, minus 54d, minus 54x. And I hit enter. Weird, but whatever. And then I say, okay, let me type in choice 1, and I choose tab. And I type in 2d, 2x. Let's do it with my mouse, it'll be better. 2x, parenthesis, d squared or x squared minus 9, x squared minus 9, parenthesis, x plus 3. X plus 3. So I've been talking about if they're equal, it'll just draw right over it. And this one will. It'll draw right over it. Oops. Can't accept change. Invalid input. Okay. Doesn't like that, so let's try it again. Home, graph, bam, tab. All right, maybe this will be better. All right, let's try it again. 2x, I'll do it quickly, parenthesis, gone it. X squared minus 9, parenthesis, x plus 3. Enter. I don't know why it's not letting me do that. All right, let's try this. Go into Scratchpad. All right, I don't know why it's not letting me do that. Doc B. Let's try this again. Well, I'm not going to do this forever. Both choice 1 and choice 4 would overlay right over it, but choice 4 is more factored because this thing was factored. So that was the tricky part of that problem. A diagram shows an angle of rotation. Which one has a diagram of an angle of rotation of 1 unit or 1 radian? Now, if you remember correctly, well, if I'm talking about arc length here, isn't arc length defined as theta times the radius? Let's call my radius r here. Let's call my radius r. So S would equal theta we want the one that's 1 radian, right? We want the one that's 1 radian. So if I wanted to know what the arc length was, the arc length would equal 1 radian times the radius, which I called r. Well, wouldn't s equal r? And the definition of a radian, 1 radian, is the distance on the circle equal to the length of the radius. So choice 1 is the answer. So the definition of a radian is the distance along the circle that's equal to the same length as the radius, and that would be choice 1. Going on to the next page. Alrighty then, I think we're on question 17. We're making some headway, kids. We're making some headway. Okay, so we basically got to solve for J. We want to get J all by itself. Right, so there it is, J. I'm done. Not going to happen, kids. Let's see if there's a couple of different ways to do this. My favorite way to do this one is to multiply through by the common denominator. So the common denominator is JWF, JWF, JWF. Well, if I do that, these J's cancel. It leaves me WF. I know you're missing a letter in the middle. W's cancel. We're left with JF. And the F's cancel. I'm left with JW. Well, I still want to figure out what J is, so I got to get the J's together. So WF is equal to, I'm going to subtract this JF. So I get JW minus JF. Now those can't be put together because they're not like or similar terms. And here's the tricky part of this whole problem. You have to factor out the J. So I end up with WF is equal to J parenthesis W minus F. So you took the J out of both of them. And finally, I just divide by W minus F, divide by W minus F, and I get what? Fun. What minus fun? Choice 3. Now, I wonder if there's another way to do this problem. There's probably a different way to do this problem, like picking a number for, let's try doing that. Let's make up a number for J. Let's say J is 2.1, so 2.1 stove J. I don't know if this is going to work or not, but I'm going to try it. Why not? I mean, if all else fails, we've got to try something. 3.5 stove W. Now, we can't make up 1 for F because it's got to be equal to. So I'm going to do control division 1 over J plus 1 over W plus control division 1 over W. And I get that. That's not going to, maybe I should have picked nicer letters. Let's do 3 control var J. Maybe I should just pick nice letters. It'll probably be easier. And I don't like doing it that way, but maybe in this case, because it's weird, I got to try it that way, because that's a weird answer. And let's try this again. Ding, 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 ding. All right, 8/15. That's not really 1 over something, isn't it? So, wait a second. Oh, well, if it equals 8/15, then I know that 1 over F equals 8 over 15, because this side is 8 over 15, this side is, so therefore F is equal to 15 over 8. Just flip both sides. So I know F is 15 over 8. So now I'm going to put 15 over 8 in for F. I'm going to use my same W, so I'm going to do 15 divided by 8 control var F. And then I'm going to say, okay, I'm going to see if this was right. Let's see. Control division. W. Now, in order to use this calculator, you have to hit times F. It doesn't work just putting WF. It doesn't understand that. W times F over W minus F. W minus F. Now, if this is right, I should get, where the heck is F? I should get J. And we said J was 3. Oh, I don't know why I put enter there. Enter. 3. And J was 3. So there's another way to do the problem. Okay, moving on. Okay, so I was trying to figure out a way to do this problem that made more sense because my brain works differently than yours. Like I sit here and I see, okay, A sub n, I should pick a different color. Let me get rid of this blue up here. A sub 1 is equal to 6. and a sub 2 is equal to, or a sub anything, is equal to 3 times the one before it. Well, what is the one before it? It's a 6. So this would be 18. And then, so that'd be a sub 2 should be 18. And a sub 3 should be 3 times the one before it, 18, which is 54. So then I say, okay, which one of these would generate that sequence? So if I plug in a 2, I should get 18. 6 times 3 squared. 3 squared is 9. That's not going to do it. That gives me 54. 6 times 3 to the n plus 1. That's weird. So 6 times 3 to the... Now, again, n is 2, so this is 2 plus 1, which is 3. That certainly isn't it. 2 times 3 to the... Again, n is 2. So 2 times 3 squared. Oh, that's 18. And then how about 2 times 3 to the 2 plus 1? That would be 54. That's not going to work. So it looks like that's the right answer. Now, why is it the right answer? I think you should understand why it's the right answer. So remember the formula a sub n is equal to 3 times a sub 1 minus n minus 1. Well, what is that n minus 1? Isn't that really 2 times 3? So really a sub 1 is, or a sub 2 is equal to 3 times 2 times 3, which is 18. But it's really 2 times 3 times 3. And then what's the next one? A sub 3 is equal to 3 times this. 3 times 2 times 3. So now I've got 3 cubed. I had 3 squared. I had 1 3. And that's why it's the right answer. Anyway, that's that. All right, the next one's really easy. Everybody should have gotten this one. You should have known that this is the directrix. And this is the focus. And you should know that, that the vertex goes right in the middle. And then the points equal distance from the directrix and a vertex is a parabola. Well, the easiest way to write that parabola is in vertex form. So my vertex is 2, negative 1. Therefore, my equation, bar any dilations, should be some number, I don't know what, it doesn't matter, x minus 2. Remember, when it goes in with the backwards or opposite sign, squared, and then minus 1. So I'm looking for the one that's got minus 2 and minus 1, and I come over here and I go, there she is. And notice it's coming down. So I also should have had a negative in front. I also should have had a negative in front. Now, how can I test that? Well, I can test that a little bit by doing it this way. It's right. I mean, I could test it by going into my graphing calculator and type it in. Negative control division 1 over 8. That's what they gave us, right? Parenthesis x minus 2 parenthesis squared minus 1, enter. And you notice there's the vertex at 2, negative 1. And that's about all you can really tell from that. So anyway, that's the answer. All right, I'll be back. Okay, the calm before the storm. I'm going to show you these ones. Again, this problem's going to take me a couple seconds. I'm going to show you how to do these problems. M plus p squared is really just m plus p times m plus p. So that's m squared, and then this is mp plus military police plus pm, which is the same as mp, plus p squared. So these add up to 2mp, so yes, 1 works. So anything that doesn't have a 1 in it has to go. Okay. X plus y cubed. Let's see what the heck that thing looks like. So really what that is x plus y times x plus y times x plus y. I'm going to deal with these two first. Now I'm going to do this a little bit quicker than I normally would, but you're going to have to bear with me. This is x squared plus xy plus xy. So that's similar to the last one, plus 2xy plus y squared. Now I'm going to double distribute these. I'm going to try to do that effectively. X times each one of these. So that's x cubed plus 2x squared y plus xy squared. And now I'm going to distribute purple. Not purple. Go blue. I'm going to distribute the y. So y times x squared is yx squared. Y times 2xy is plus 2xy squared. And then plus y cubed. So I hope you see that this one's not going to work out. This is x cubed plus 2x squared y, and x squared y is 3x squared y plus 3xy squared plus y cubed. So this one doesn't work. Anything with a 2 in it has to go. So now I got to decide if 3 is going to work. Now that's the tricky part. If I double distribute, having a hard time moving, I apologize. If I double distribute the left side, if I write this twice, a squared plus b squared times a squared plus b squared, I get a to the fourth. Now this is a squared b squared. This one is a squared b squared. So that's plus 2a squared b squared plus b to the fourth. Well, that does not appear to be this. But it's hard to tell. It's really hard to tell. So I'm going to do that one in red. So that one's really a squared minus b squared squared. So that's a squared minus b squared. Plus, now this is the hard part, 2ab squared. That's the tricky part, I think, right there. So I double distribute all this one out. I get a to the fourth minus a squared b squared minus a squared b squared, so that's minus 2a squared b squared, plus b to the fourth, plus, now this thing squared, be careful, the 2 has to get squared too, is 4a squared b squared. So if I combine all this stuff up on the right side, I get a to the fourth. Now, negative 2a squared b squared and 4a squared b squared is plus 2a squared b squared plus b to the fourth. So you'll notice that they are in fact the same. Ergo, the answer is choice 4. Now, you could have done this stowing in some values and checking it that way as well. Whatever. All right, let's do this one. It appears to be a cubic function. It's got 3 roots. My 3 roots are 4, 0, and 3. Now, the question says, if I divide p of x by x plus 4, what's my remainder? Well, you need to be able to say, oh, wait a second. If that's a cubic function, then I know that p of x is really equal to x plus 4. Now, even this is negative 4, right? So when it goes in as negative, positive 4. The middle one is just x, and the last one is x minus 3. Well, I need to divide by x plus 4. So when you divide by x plus 4, remember, we're talking about the remainder. Well, if I divide that, doesn't this divide in evenly? Those just cancel. I have no remainder. So in this case, using the remainder theorem, my remainder would be simply 0. And that's the answer to that question. All right. Okay, this question. It's another one of those ones I was sort of hoping to get the answer key for, but I don't. So I'm going to need a little bit of a coffee. Very good. All right, let's talk about this problem. First of all, this is called loan sharking. A 30% interest is loan sharking. You can't charge 30% interest. You go to jail. So, let's see what happens. Here's what happens. Here's the problem. Check this out. You start with $300. Now, you're going to pay 30% of that. Now, you need to be smart, right? I'm not making any payments, so I'm getting hammered with fees. It's just going to keep going up and up and up. Now remember, this is interest that's compounding. It's increasing. So it can't be less than 1 because these are decay questions. So these answers don't make any sense. So I hope you didn't pick them. So now I'm down to choice 2 or choice 3. I don't like this question because the end result answer is ludicrous. I'm going to put both of these in. I'm going to put both of these in my calculator and see what kind of answer I get. So 300. Let me get rid of the crap from before. Okay, I got you. 300, parenthesis, 1.30. I don't know how I got that. Escape. Just keep hitting the wrong buttons. 1.30 raised to the 14, raised to the control division, 14 over 365. And you get $303. So if you think you're going to loan or take a loan out for $300 at 30% interest every 14 days, and you're only going to have $303 at the end of the month, that's kind of ridiculous. So that's sort of a ridiculous answer. But let's put the other one in, because this one is probably going to blow your mind. And if you don't understand money, and if you don't understand loans, then this answer makes no sense as well. 365. 200 and, did I type that in wrong? 365 over 14, 300, 130. So $280,405. $280,405. What? So you take out a loan for $300, and at the end of the year, you owe $280,000, and hopefully you did enough discussion about exponential regression to understand this. Let's see if we can come up with that number. Oops, excuse me. Escape. Whatever. Enter. So I'm going to type in 300, and I'm going to put enter. I'm going to do recursion on this one. So I'm going to do 1.30 parenthesis second answer parenthesis. Oh wait, hold on. So recursion just means that I'm going to take my answer, second answer, and I'm going to multiply by 1.3. That's 30% increase, 1.30. That's 30% increase. So at the end of 2 weeks, I owe $390. At the end of 4 weeks, which is the end of the month, I owe $500. At the end of 6 weeks, I owe that. At the end of 2 months, I owe that. 3 months, 4 months, 5 months, 6 months, 7 months, 8 months, 9 months, 10 months, 11 months, 12 months. I think I'm off by 1. Whatever. I'm a little bit off by 1. It's not quite exactly, because remember, there's actually 20, that would be actually 26 pay periods. So the answer is choice 4. This is the answer. But I know that answer is like, what? That don't make no sense. And I think if you put the other ones in your calculator, you actually might get a better answer, but they're wrong. The answer is choice 4. Tough question. Tricky question. Which value is not contained in the solution of this thing? So I'm going to show you. Hold on. Let me see how much time I got. I'll be right back. So I'm going to show you how to do this problem using the graphing calculator, and we're going to use matrices. So what I'm going to do is I'm going to come in here. Oops, I meant to get rid of everything. So control history, enter. So I'm going to come in here, and I'm going to go into matrices, this one. Press enter. Now, how many rows do I have? I have 3 rows, but I have 4 columns because there are 4 things, right? If I go over here, this is 1 column, this is 2 columns, this is 3 columns. Maybe I should be writing these. 1 column, 2 column, 3 column, 4 column. Okay? And I'm going to put the numbers in. So I'm going to look down 1, 5, -1, -20. So that was my first equation. Make sure all the letters are lined up. 4, -5, 4, 19. Now put the last one in. -1, -5, -5. This is one way to do this problem, and 2. And now I'm going to store this into, I don't know, who cares, K. I'm going to store it into K. There's K. Now remember, the first column is A, the second column is B, the third column is C, and the last column are the constants. So whatever I come up with for A, you'll see how this works. So what I'm going to do is go into this catalog, and I'm going to look for RREF, reduced row echelon form. Linear algebra at its finest, reduced row echelon form. So this is an easy way to do it, RREF. There it is. So so I'm going to just double click on it. I want to RREF K. So I'm going to reduce row echelon form K, and I hit enter. There it is. And what does that mean? Well, the one here in the first column represents A. A is -2. The one here represents B. B is -3. And the one here represents C. No, wait. Yeah, C, and C is 3. So I know A is -2. B is -3. And C is 3. So which solution is not shown below? Well, let's see. There is no +2. So my answer is no +2. So that's one way to do the problem. Another way to do the problem is to go back to your calculator. And I always forget how to do this way. Control, let me get rid of what I have there. And I'm going to go into Menu, Algebra, and I'm going to solve a system of linear equations. How many equations do I have? 3. It's going to say, okay, we're going to call them X, Y, Z, but I don't really want to call them X, Y, Z. I want to call them A and B and C. So you can call those anything you want, change those to whatever you want. So then I get this, okay? So now I'm going to type my equations in. My equations are A plus 5B minus C. My second equation is 4A minus 5B minus 5B plus 4C plus 4C. And again, all of this stuff, if you don't know how to do these, can be found at www.nkinfinity.com, where I show you how to do a few problems like each of these, so you have these as a means to solve later. And if you forget how to do this at the end of the year, go back, watch those videos, and you can see this again. So negative A minus 5B minus 5B minus 5C minus 5C equals, oh, I forgot to put the equals on these. Equals is right here, equals 2. Equals, of course you got to have that in there, 19, otherwise it doesn't make any sense. And up here, equals negative 20. So I type that in exactly as I got it. And I'm solving for A, B, and C, and I hit enter, and there it is. A is -2, B is -3, and C is 3. There's another way to use your graphing calculator to solve this problem. Okay, that is those two questions, and I got one left. Oh, I did not like this question. It's another one of those questions I didn't like, but it's pretty easy. We're assuming a 1.5% growth rate, a 1.5%. Now don't forget, 1.5% is really equal to 0.015. So if I want 1.5% growth, not decay, but growth, then I need 1.015. So anything over here that doesn't have 1.015 has to go. Has to go. Doesn't make any sense. There's got 1.015. That's got 1.015. And that has 1.015. Let's see. All right, so that doesn't make any sense. So now let's see. In 2010, the population in New York State was approximately with an annual growth rate of 1.5. Assuming growth rate is maintained by large numbers, which equation can be used to predict the population in New York State T years after 2010? Well, this is just a simple recursive sequence where we're saying, okay, we're going to start out with this much, and we're going to multiply, or we're going to increase by 1.015%, or 1.015% times the previous year. And so the answer is choice 4. All right, kids, that ends the multiple choice. I hope you enjoyed your show. Goodbye. Hit subscribe, will you? Please, come on.